All right, let's do the second half of 3-5. And don't forget, you need to know all the trig derivatives, all 6 of them in order to do these. Okay? Okay, here we go. We're going to talk about simple harmonic motion, which I know I assigned some problems to you last night that I shouldn't have. But simple harmonic motion. So we already know that the derivative of the path of an object, the first derivative is velocity. Second is acceleration. We're going to learn that the third derivative is jerk. Now, if you think about like someone who accelerates really fast, it's really a jerky ride, right? It's the change in acceleration makes it jerk the way it does, okay? All right, so here we go. It says here that we have a weight on a spring like this, okay? Yep. And what we do is we're going to pull that spring down, and then we're going to let it go. So what's going to happen is it's going to bounce up and down, and it ends up having a simple harmonic motion. And so here's the motion that is given by this spring going up and down. Oh, we're going to call this number 1. S equals, let's call it S of t. S of t is equal to 5 cosine t. Okay? The rest is at s equals 0. So the book looks like this. It goes all the way down to here. And what happens is this is the rest area here. And so you have it resting, and when you pull it back down, it'll go back up, and it just keeps going in a cosine manner. Okay? All right. Now, we are going to do a couple of things. We're going to, A, find the velocity equation. Okay? So let's go ahead and find the velocity equation. The velocity equation you can write as v of t if you want to, or you can write s prime of t. Either way, it doesn't matter. So let's take the derivative of 5 cosine t. What's the derivative of 5 cosine t? Perfect. Negative 5 sine t. Okay, the derivative of cosine t is negative sine t. All right, the second question I'm going to ask is, now find the acceleration. Acceleration. So you can write that as a of t, or you can write that as v prime of t, or s double prime of t. There's a lot of different ways to write that. We're going to take the derivative of the velocity, because that's the change. The acceleration is the change in velocity. So you take the derivative and you get, good, negative 5 cosine t. Okay? And then finally, the last thing that we're going to do is something new, is we are going to find the jerk. He's gone today. He's at, where did you guys say he was?
Greg, he's at.
Oh, yeah, he's at, yeah. Okay, the jerk. And the jerk is the change in acceleration. It's the change in acceleration. So we can write j of t. And we just take the derivative of the one above. So negative 5 cosine t, then that would be positive 5 sine t. Okay? And so then if they ask you what is, the acceleration at t equals pi over 2, they always give you nice radians and stuff. You just plug it into the acceleration formula. All right. Did that. So then let's do this in not a cosine or tangent kind of matter, or sine. Let's do this. Let's say you have a falling object or something like that. And let me give you the motion is s equals 16t squared. Okay, you have a simple parabola. If you want to find the velocity of this, all you do is take the first derivative. Velocity is 32t. The acceleration would be 32, and the jerks would be 0. There's no jerks, like our class. No jerks in here. Yeah, it's cute, huh?
Yeah, I'm sure about that.
Pretty sure.
Right now.
Okay, so that's pretty much it. It's pretty easy that way. Just, velocity, acceleration, jerk. That's it. All right, now I want you to do is I want you to practice one of these, number 3. here we go. We're going to have y equals 5x plus 3 tan x. And I want you to find the derivative. Okay? Just very basic, just to review, just to practice a little bit. Something like this. Now what I like to do is I kind of stand back and go, okay, what am I going to do here? Do I need to do product rule at all? Do I need to do quotient rule? The answer to both those questions is no. There's no product rule here, and there's no quotient rule here. Take the derivative of 5x, and what do you get? 5. Perfect. Take the derivative of 3 tangent x, and you get? Perfect. 3 secant squared x. And some of you are sitting there like, how did you get that? Well, you memorize. You will memorize. You'll have it down by tomorrow. Pretty sure. Number 4. Now something like this though, y equals 2x cosecant x. If you want to find the derivative of this, it's much trickier, as you know. Okay, this right here is going to be product rule. Okay, you have 2x times cosecant x. And so this is A and this is B. So let's do it.
Is it because they're both x's?
Yeah. And because, yeah, it's not like you have a constant times something. It's different. Yeah, because they're both x's.
If it was just a 2, you just leave it there.
Yep, exactly. All right, so here we go. We're going to do A times B prime. What's the derivative of cosecant x? Do you know that one? I think it's negative though, right? Oh, you did. Good. Do you know these or are you looking at them? Oh, okay. He's looking at them. All right. Negative cosecant x, cotangent. So A, B prime plus B times A prime. Derivative of 2x is 2. Okay. And there's really no like identity switches around here. What you want to do is you want to pull that negative out to the front and you just clean it up a little bit. Okay, and then take that 2 and move that to the front also. You don't need to factor out a cosecant x from both terms. That would be your answer, and you leave it. You can if you want to. You can factor out a 2 cosecant, yeah, but you don't need to. Yeah? These aren't too bad, huh? All right, let's do a quotient rule now. Number 5. 47? Let's do, we did that one on the homework. We'll find like a super fun one that you'll like. Let me see. All right, found one. Let's go y equals x over x plus sine x. Okay? And let's find the derivative here. And what we're going to do is we are going to find the slope at x equals pi. Okay? Find the slope at x equals pi. It's a little different, isn't it? But if we want to find the slope at anything, we have to take the derivative and then plug it in. Okay? At x equals pi. All right, so let's take the derivative. The derivative here, we're going to need quotient rule. We have a function divided by another function, no constants, okay? So we're going to go low d high. So low d high. What's the derivative of the numerator? 1. Good. Minus high d low. The derivative of the denominator? 1 plus cosine x. Good job. Over the square of what's below. X plus sine x squared. Okay. So now let's go ahead and let's fix this up. So you get x plus sine x. Okay, so it's just 1 times x plus sine x. Then we have a negative x times 1 plus cosine x. So that's going to be negative x minus x cosine x all over x plus sine x squared. All right? No? I saw a no. Yeah? Okay, I see a yeah. All right, so now the x's are gone. And then you end up getting y prime equals sine x minus x cosine x all over x plus sine x squared. It is pretty nasty. It's not very good, is it? All right, but that's as simplified as we can get it. So now let's go ahead and find the slope at x equals pi. Okay? X equals pi. Now, pi is a nice number. Nice number when you're doing sines and cosines and stuff, right? Do you remember what the sine of pi is?
Nope.
No.
You tell. Plug it into the calculator. Isn't it 1?
Is it?
I don't.
I think of the sine wave.
Why did you guys grab through it too? I feel like I don't think of any function.
You don't? It's 0. So I think of sine as 0, pi over 2. No, that's pi. And that's 2 pi. Yeah, I haven't done these in a while either. Okay, so 0. The sine of pi is 0. You think of the unit circle? Yes, that's good too. If you think of the unit circle and you go to pi, the value there is -1, 0. Remember, sine is the x or the y number, and cosine is the x number. All right, so we get 0 minus pi. What's the cosine of pi? -1. Good. Over pi plus 0 squared. This is going to reduce nicely. Up top we get pi. On the bottom we get pi squared, and so the slope of the tangent would be 1 over pi. Let's see if inderiv works. Are you wondering if inderiv works on that?
That involves a calculator.
Okay. Go to Math 8, and let's do the derivative of x divided by parentheses x plus sine x. Close the parentheses at x equals pi. You have to make sure you're in radian mode. And I get 0.318, and you know what that is?
That's 1 over pi.
It is. It's 1 over pi. Okay, but if I asked you to do this, and I said leave it in terms of pi, and you write 0.318, I know you did your calculator. It's good to check. It's a good check.
You plug in like pi divided by 2.
You just keep plugging them in?
Yeah.
That